Good afternoon. In this video, we are going to see about graph theory. Graph is a non-linear data structure. As you people already know, difference between linear and non-linear. This comes under non-linear data structure. What is meant by linear? It is coming one by one another one. Yes, but in graph, it is non-linear. We cannot specify. This will comes under next one and next one and all. You have more than one subdivision as like your tree. So this will be called as non-linear data structure. Here graph will be represented with the keyword G, and it will be consist of V and E. V is nothing but vertices, and it is also called as nodes, and E will be called as edges. So here the graph may be consist of many number of vertices, that is finite number of vertices and edges. Here consider this as a graph. It consists of V1, V2, V3. These things will be called as vertices. It is also called as nodes, and it is linked by or connected with edges. So this connection is called as edges. So you have a definition. Graph is a collection of two sets of V's and E's, where V is in finite number of vertices and E is in finite number of edges. It will not be negative. Then graph have two types. One is directed, another one is undirected. Consider this as an example. Here V1, V2, V3, V4 are vertices, and E1, E2, E3, E4 will be considered as an edges. Here you have arrows, that is within direction. Arrow symbol is here, no? So if your graph consists of arrow, that is pointing direction, means this will be called as directed graph. It is also called as ordered graph. Here same graph is represented, but without any direction. So this will be called as undirected, and is also called as unordered. Here you can specify this particular graph like V1 and V2. V1 will be head and V2 will be tail. So you cannot specify this particular thing in V2, V1 because it is directed one. So these two things are not same. Here for edge E1, you can represent V1, V2 or V2, V1. You can, both are one and the same because it is non-directed, that is undirected. Now we are going to see a concept called multigraph. Here you have vertices V1, V2, V3, V4. Multiple times graphs are nodes are connected. So this will be represented as multigraph. Now we are going to see properties of graph. Here you have three properties. One is complete graph, another one is subgraph, another one is connected graph. So here you have four vertices V1, V2, V3, V4. So it is connected with 6 edges. So you have a formula called n of n minus 1 by 2. So here you have four number of nodes. So 4, we are going to substitute n with 4. So 4 into 4 minus 1 by 2. So here you will get 6 as an answer. Here in this graph you have 6 edges. So it will be called as complete graph. And you have a subgraph. This will be an whole graph. In this will be called as subgraph. So you can specify this also an subgraph, and this will be also called as subgraph. And then connected graph. So in connected graph, every pair of edge vertices are connected each other. This will be called as connected graph. Now we are going to see representation of graph. Graph can be represented in two ways. One is adjacency matrix, another one is adjacency list. Here you have a graph V1, V2, V3, V4, V5. So this can be specified as a matrix. Here you consider V1 to V5 and V1 to V5. So for this matrix, if you have any connection with V1 to V1, whether do you have any loop connection here? No, right? So you can specify 0 here. And then from V1 to V2, do you have connection? Yes, no. So here you have to specify 1. In same way, V1 to V3 you have connection. So here you have to specify 1. For V4, whether you have direct connection from V1? No. For V5? No. So you have to specify 0, 0 here. From here, for V1 to V2, this will be considered as V2. So from V2, do you have connection to V1? Yes. So 1. From V2, do you have connection to 3? No. So it is 0. So from V2 to V2, do you have connection? So 0. So from V2, do you have connection for V4 and V5? For V1, you have connection. So it is specified as 1. And for V5, you don't have connection. So it is specified as 0. The same way, you have to specify this matrix. So this will be adjacency matrix. In this way, you have to mark 1 for connection and 0 for if you don't have connection. Then we are going to see an adjacency list. So this will be a method 1. Here you have arrays. You have an individual head. So these are the matrix, node name. So A, B, C, D, E. So from A, do you have connection? You have to specify for the adjacency connection. Adjacent connection in the sense immediate connection with the node. So from A, you have connection with B and E. Yes. So you have to specify A, then E. After that, do you have any connection, direct specific connection? No. So that will be marked as null. The same way, from B, you have connection adjacency nodes as C and A. So you have to specify A and then C. Next, from C, you have connection with B and D. From D, you have connection with C and E. From E, you have connection with D and A. So in this way, you have to specify your adjacency list. This will be one method. In another method, you have an array with the head. This will be individual head. Here you have an array head. Here you have specifying head of 5. So 0, 1, 2, 3, 4 as like array it will be specified. And then you have to specify as like before. You have to specify the adjacency nodes. This will be method 1 and this will be method 2. Here you have an head. It consists of data and down and the next. These are the pointers. In the node, in this node you have vertex variable name and then you have link. Here in second method you have node in vertexes and then your next pointer. And you have a head of 10 size or 5 size. It depends. Now we are going to see a few more concepts. Weighted graph, strongly connected, weakly connected, loop, path, length, simple loop. Likewise it goes on. Here we have weighted graph. If you have, this will be called as directed graph and this will be called as undirected graph. If you have number for or weights value, this value will be called as weights. So if you have weights for these edges, then it will be called as weighted graph. Then you are going to concept called strongly connected. If you have more number of connections, then it will be called as strongly connected. If you have single connection, then it will be called as weakly connected. If you have self representation, then it will be called as loop. For path sequence, from V1 to V3, how you can reach? You can come in direction V1 to V2. Then no, you don't have any connection here. In the same way, in this graph, we have to visit V1 to V3. So from V1 to you can go to V2, then V3. So in this way, you can move to your V1 again. So this will be path. Then you have to specify the length. How you can calculate length? So from V1 to V3, you have edges. Yes, how many edges you have? 2 edges. That will be called as length. Here you have a formula called n minus 1. N is number of nodes. So you have 3 number of nodes. Minus 1, 2. So 2 edges you have, right? So that will be called as edges. Here you have a concept called simple path. Here from V1, V2, V3, you don't, first node and last node are distinct. So this will be called as simple path. And you have a concept called simple cycle. Here is your starting node and your ending node will be the same. For example, this will be form and cycle. A to C, C to B, B to A. So this will be called as cycle. So here this is also called as cyclic graph. Here you have a connection from A to B, B to C, C to A. So this will be forming a cycle. So this will be called as cyclic graph. And you have a concept called acyclic, that is you don't have any connection from first node to the last node, that is you don't have any cycle. So this will be called as acyclic. Here also you have single directed and also bidirected. So here you have a concept called directed acyclic graph. Directed means you have direction, acyclic means it should not form a cycle. So in this is an example for directed acyclic graph. So you have direction and you should not form a cycle here. Then this will be an important concept. Based on this we are going to solve some sums. Here you have a concept called degree. It is already mentioned in your tree. So here we have two things. One is in degree, another one is out degree. Consider this as this graph. Here you have for V1 you have two in degrees. In degree is nothing but the edges passing towards V1, and out degree is nothing but coming from the node. So for V1 you have two in degrees and V1 you have one degree. So in degree is 2 and out degree is 1. For V2 you have 1 and 2. V3 2 and V3 for out degree is 1. V4 1 in degree and V for out degree is 2.